All right, so let's continue. So right now I draw my truss. I can finish the drawing. Actually, I was showing you how can I draw with the quick tool, this one. This is just like when you pick the grid, it's gonna draw something, but this is not gonna work if you don't have a grid. If you don't have a grid, you have to pick the draw frame, and then you will have to start picking the first point, the last point, and then draw your truss, okay? All right, so this is a one way to do it, but right now it has a random section that I'm not sure what is the section as. So I have to assign a section to this, but to do this, I need to define the material of this section and the geometry of this section, okay? So to do this, I can go to define, and once I go to define, you will find materials. So you can go to materials, and here you will find two materials that the software already defined for you. One of them is a concrete. The compressive strength is 4,000 pounds per square inch. And there's a one that has a steel material that the F yield is 50. That's the name of the material. Okay, so let's go check each one. If you want to check each one and modify, you can click modify and show material. And once you click on it, it's going to show you everything about this material. Like what is the like for example here, this is the name of the material or the grade. So the characteristic compressive strength is 4,000 per square inch, but this is just a name. You can write whatever you want. You can say concrete 40 or concrete 4,000. What is the most important things are the inputs like this. What is the weight per unit volume? Sometimes we use lightweight concrete in a slab. So you have to define what is the on weight, what is the density of this concrete. This is 2.4, one can be 1.9, can be 2.1. And definitely make sure that you have your material right. It gives you sub-material here. Sometimes we have the material as in terms of different units. So once you change this unit, like let's say change this to Kip's feet. Let's see what happened. It's completely different value. So let's assume, for example, I already have the characteristics of concrete as a Kip's feet, but my project is ton meter. So you can change this to Kip's feet, put the unit, and then it's gonna be converted. Once you convert this, like if I go to ton meter, it's gonna be converted, right? Okay, then you will have the Young's modulus, which is one of the most important characteristics of the material. And we discussed this one time before, how we can get it. There's a way in the code to do it. I believe it's 4,700 or 4,500 if it's root the FC. So you go back to your rules, check the code, calculate your FC, and then you put sorry, calculate your Young's modulus and you put it here. And this is the Poisson ratio. You put it as well. And I believe if you are doing thermal analysis, you have to include also the thermal expansion for the thermal coefficient here. And if you are going to do design, this is going to be very important. Like you need to have FC right. If I'm not going to do a design, I'm only going to do structure analysis, like what we are doing this class. I don't care about the concrete materials problem. Okay? Because when I do design, yeah, I care about the compressive strength of the concrete. But if I'm not doing a design, I'm only doing analysis, I want to get forces. So this is the very important part. Young's modulus, moment of inertia. This is all what we deal about. You will never see a structure analysis class that we deal with what is the F yield of the steel, what is the FC of the concrete. We don't do this. We only use them in the design. Okay, so let's say that we are okay with this material, and then I will hit okay. If you want to modify and keep this material here, you click add a copy of the material. Add a copy, and then you change whatever you want in this material, like change the compressive strength, change Young's modulus, okay? So if you want to add a new material, like let's say there's a steel and concrete, but you want to add aluminum. So you go and add aluminum and pick an aluminum material from the library. But I never did that. I only dealt with steel or either concrete. Okay. All right. So I have these two materials. If you want to look at the steel, you go modify and show. And then like in my project, the project for this class, I'm going to give you what concrete that we are going to deal with, because we are going to have a tall building. For the tall buildings, there might be many materials. Why? Like, for example, we are going to use ultra high performance concrete for the columns. We need a very, very strong concrete for the columns, like compressive strength maybe double this number. But this is I'm gonna use for the columns, and it's a very, very expensive concrete. Should I use the same concrete in the slab system? No, the slab system take bending moment, so it doesn't has to be the compressive strength very high. So maybe even use lightweight concrete to decrease the weight of the structure. So we might have different material for the column, different material for the beams, different material for the slab. So that's why we need to define different materials. Same thing for the steel. We need to use like very like a different rebar for the columns and different rebar for the slab. Okay. All right, so that's a little bit of brief on the materials. So let's say our truss is gonna be this material, the steel material. Okay. All right, we're gonna use this one, the FY50, and I'm gonna say okay. The second thing that we need to define is the sections. So I go to section properties, and then I will go to frame sections. I don't have slabs right now. Most of my elements are frame. So I go to frame, and then I will find one section. If we didn't draw, we'll find this empty, but we draw something. So the software started to assume a section is called F section 1. So let's see what kind of section did the software did here. I'm gonna go to modify and check that section. Sounds like the software made like a steel cross section, and it gave it a name and it gave it dimension. If this is not the section that you're dealing with, you have to adjust it. Like, let's say my truss is going to be a concrete. So I'm going to click X, and then I'm going to add a new property. On the top, I will find that here it's on a steel. I'm going to go to concrete. In concrete, they have multiple templates. I'm going to use rectangular sections. And then, for example, I'm going to name this section beam, for example, 30 by 70 centimeter. And then here, I'm going to make the depth is equal to 0.7 because the units are in meter. You can name here whatever you want. You can name it 0.3 by 0.7, 30 by 70, or 300 by 700 millimeter. So the names can be anything, but this is the actual input. So I'm going to change this to be 0.3. All right. So once you change this, it's going to show you the template that you are going to have. And you can change the material. Like if this is a column, you can change the material here. So I'm going to say that this is a concrete 4000 PSI. All right. So once you are done, you can hit OK. There's something here, it's called set modifiers. We're going to talk a little bit about the modifier when it comes to seismic. But basically, modifiers is, like, for example, let's say that you are designing a section. And sometimes in our design, we assume cracked sections. So if the section is cracked, then it's going to be designed as cracked. So that means the stiffness is not 100%. So it's going to lose part of its stiffness. So sometimes we're going to change the stiffness, the moment of inertia, not to be 100%. It's going to be 0.7. Sometimes it's going to be 0.3. Sometimes it's going to be 0.5. It depends on the element and depends on what hazard that we are dealing with. Okay. So sometimes the stiffness that we're dealing with is 100%, but also there's other applications. Sometimes you do forensic analysis for structures that already have been built for 50 years and the sections are deteriorated. So when we model them in SAP 2000, the stiffness sometimes is not 100%. Yeah, the cross section is 1 meter by 1 meter, but it's cracked from different places. So maybe you need to reduce the stiffness of the elements if the structure is deteriorated. Yes.
When it's cracked, we use 0.3 or 0.7?
It depends on what the code is saying. Like for seismic analysis, the code says the columns need to be 0.7, the slab need to be 0.5, the beam, whatever like the numbers is. And it's different from code to another. Some codes, they are conservative, some codes are not conservative.
And then the stiffness is at 30%, 50%, or 70%.
What was that?
Like when we modify it, we say like there's exactly 30%, 50%, or 70% of the stiffness.
That depends on the element and depends on the loads that we're dealing with. But if you have a structure, like let's say the column behind you, and this column is like cracked.
Yeah.
So maybe you look at the width of the crack, maybe you look at the size of the crack, and ask you based on the crack, how much of this area is not contributing to the total stiffness of the element. Okay. All right, so this is the parameters. We are gonna get in deep into the modifiers, but I'm not gonna change the modifiers right now. Okay. And actually, you know what? Sometimes I'm not sure if you guys face these problems or not. Sometimes in structure analysis and advanced ones, you have a member, like I don't give a cross section. I tell you that this section of stiffness is EI and this is 2 EI. That means that this is double the stiffness. So maybe you assume a cross section, one cross section, and double the stiffness for one of them here. Okay, rather than developing a section that has I and trying to find out how to make it 2I. So sometimes we multiply the stiffness by 2. Okay. All right, so this is for the modifiers, and then I will say, okay, once you define this, it should be getting down there, and it's gonna be something like this. All right. So right now I define the sections. I told you we define material, sections, and then load. So I will go down. You will find something is called load pattern. Load pattern is what type of loads that you are going to use in your analysis. In my analysis, I will go to the AutoCAD file. I'll find dead load and live load. So I only have 2 load patterns. Sometimes we have rain load, snow load, earthquake, wind. Okay. But right now I only have dead and live. So I'll go back. I'll find that he already defined the dead load. It's already there. And all what I need to do, I need to add the live load, but I need you to look at this. Has the load pattern name and the load pattern type. You can actually name it flowing. The flowing is a bit or whatever. Okay, but it's the type is dead. And you have the self-weight multiplier. What is the self-weight multiplier? The self-weight multiplier, SAP 2000 is asking you, do you want me to calculate the own weight of the structure and add it to the dead load or not? If you put 1, that means that you want SAP 2000 to add 100% of the own weight in this load pattern. You can define, for example, I can define live load. Let's say I'm gonna make a new one and I'm gonna name it live. No, live. And then I will come here, I will have live load. And the self-weight multiplier is 0. That means that there's no dead load. But if you put 1 here and you add, so the SAP 2000 is gonna calculate the dead load and add it to this load case. So that means you are telling SAP 2000, calculate the self-weight and add it to this load pattern, but I'm not gonna do this. Actually, I'm gonna put 0 here, I'm gonna add new load pattern. Not only this, I will go back to the dead load and I'm gonna make it 0 and I'm gonna modify this load pattern. Why? Because I didn't tell you that the problem has an own weight. I don't want you to calculate the own weight of the structure. Okay, if I told you calculate the own weight of the structure, so you might do this, but I don't want to do this right now. It's just a simple truss. I give you the loads as a concentrated on the joints. I don't want you to include dead load. But let's see what happened if I'm gonna make this one. Okay, I'm gonna make it like this. I'm gonna modify it and I'm gonna hit OK and see what is gonna happen. Okay, you have a question?
No.
Oh, all right. Oh, I see I have a member here that was drawn by mistake, but actually I'm gonna, so, all right, let me. Click on this. I'm gonna delete this one. That's actually the benefit of having 3D, that you can check if you draw something by mistake. All right, so the deal now, we draw this with a random cross section. If you want to keep it, we can keep it. But if you want to assign the new section, you can select all the trusses that you have and then assign the new section. You will find here a panel is going to have assign, and you go to frame, assign frame section, and then you pick the frame that you want. We have the frame section one, the random one, and we have, I don't know, I can't find the one that we defined. Let's see, frame sections. Oh, did we say save? Maybe we, oh, okay. All right. Okay, let's do it very quick. I'm gonna add new property. And rectangular. All right. Okay, so the thing is, I believe it was here, but I didn't click OK. Maybe I clicked the X or something, so I have to do this. Once I do it, I will find the cross section here. So once I click on beam, I'm gonna hit OK. So all of them are gonna have the new cross section. If you want to make sure that the cross section is assigned, actually SAP shows you that all the names here. If you make a right click on any member, it's gonna show you all the property of the member. Like here, it give you the section, it give you the like the units. If you go down, this is actually for the assignment. There's no loads in this cross section. Okay. All right. So right now we have the materials, we have the cross sections, we draw. Okay, so right now, is our structure missing something at this point? What is it? Boundary conditions. And then the support is the boundary condition. So I have here the boundary condition here, boundary condition here, and then I have the loads. Okay, I have roller here and I have a hinge here. So the boundary condition is something assigned to a joint. So I click on the joint and assign joint thing. Okay, let's see what is the joint thing that we need to assign. So I'm gonna click on this joint. By the way, I want to teach you something. If you make a click from down to up, it's gonna click anything that is full inside this box. Like, see, I only clicked on this point. But if I make a one from top to down, like top to bottom, it's gonna also take the members. Can you see? So I can escape this and I can write this. But you know what? Actually, you can do this and you are selecting what I'm selecting right now, a joint and two members, right? But if you go to assign joint, and then that means that anything you are gonna do right now, okay, right now I select joint and frames. Anything that I'm gonna assign right now is gonna be, once I click joint, that means anything that I'm gonna do now is gonna neglect all your assignment, only focus on the joint. Okay, so it doesn't matter if you have joint and frames in your selection, because right now I'm gonna only doing something related to joints. So what I'm gonna do to the joints, I wanna restrain these joints. So I go to restrain, and then you will find all the boundary conditions that you wanna do. Like, do you wanna restrain all the translations, all the rotations? You can do this. And also gives you, if you wanna do, like, actually, what we want to restrain here right now. What kind of translation and what kind of rotation? Do we want to restrain any rotation? No. Okay. What do you want to restrain? Translation. In what direction? 1, 2, or 3. 1 is X, 2 is Y, 3 is Z. Z, right? Because roller is only restraining the movement here, but it allows the movement this direction. And we don't have anything in this direction. So rollers, like you can either uncheck these and say, okay, or right away put a roller. And actually, like, let's say that we have all these are checked. And I just clicked roller, is gonna remove all of them. Okay, then I will hit actually apply. Apply means that it's not gonna close this box and it just put the roller and the assign is still active. I can click on this and do another assign. If you clicked OK, it's gonna close this box and you have to go to assign, joint, restrain to open this box again. But once you're still in the assignment process, keep this box open, okay? So here, I'm gonna put hinge, I'm gonna click on hinge and then I'm gonna hit OK. All right, so right now I have a roller and I have a hinge. The next thing is the loads, all right? So I define dead and live loads. So I have in these two joints, I check these two joints, and then I go to AutoCAD, I have 4.2 ton and they are dead loads. So I will go here and then I will go to assign. Here there is a joint and here something is called joint loads. If you want to assign joint characteristics, it just be only joint. If it's loads, it's going to be joint loads. So what do you want to assign? Force or displacement? Forces, right? Okay, so I'll come here. You guys tell me, do I have to change this to other load? No, right? It's gonna be dead load. And you tell me what is the, where should I put the 4.2? And which one of these? Z, right? Force in a global Z direction, okay? And is it positive or negative? Negative, because it goes down. All right, so I'm gonna say here, negative 4.2, and then, okay, that's very important. You have to always have it as a replace existing load. Let's say that you put the load 4.2 positive, and you went back to change it, and you put another load, and it wasn't replace existing, it's gonna be added to the existing, okay? So replace existing means replace what is load. So it was 0, replace it with the new load. So I'm gonna say replace existing, and then I'm gonna hit apply, because I still need to apply more loads. I'm gonna click on this. I'm gonna check what load do I have here. It's a 5.5. So I'm gonna put here negative 5.5, and it's Z. I'm gonna hit apply. All right, I added all the dead loads. The next thing, I have a live load at this joint. Let me go in and check on AutoCAD. I have 5-ton live load in positive or negative. Positive, what direction? X direction. So I'm gonna go here. I'm gonna, okay, I have to change this to live. That's the first step. I have to put 0 in Z because this load is not in Z direction. And I have to put this as what? 5. Okay. And I replace existing, I hit apply. Once I hit apply, the other loads hasn't been removed. It's a different load type. So this screen is only designed to show one load type. So it's only showing live load right now. Look, joint load live. If you want to show a different load type, you can go here. Let me check. Okay. I will go to display. And then I will show object assignment. Show object load assignment joint. And then you will change it from live to dead. And then I will hit apply. So you'll find the dead loads that you have. If you want to show the live loads, you click live and you hit apply. Okay. Is there anything missing? There's lots of things missing. We did lots of mistakes here. That's what I want to teach you, but I'm going to run this as is and see what mistakes that we have here. I hope that we will have time. Okay. So there's lots of mistakes. One of them you already know, right? I believe we lit something and I told you I'm going to show you at the end. What was that? No, I believe I told you guys I'm gonna leave it and see.
Look back now.
Oh yeah, I left it 1. Do you guys remember the dead load? When I said that we need to make it 0, I'm gonna keep it 1 and see what's gonna happen. There's other things other than that. Okay.
Release the modes and
Exactly. This is one of the things. I'm gonna talk about the release. Okay. So there's lots of stuff we're gonna see how it's gonna happen, and then run the analysis and see how's the analysis look like. That's why I want to teach you how the garbage in, garbage out is going to look like. Right now, we have completely different problem than done in AutoCAD. Maybe it seems to you it's perfect and it looks good and it's ready for analysis, but it's not. We have to do other things. Okay, let's run and see how we can discover these things. All right. I'm going to run this. All right, I'm going to save it. Let's say run now. All right, this is how the transdeformed shape look like. If you want to see, all right, if you want to see the animation, well, the truss looks okay. I mean, like as a deformed shape, that's actually the deformed shape due to the dead load. If you want to show the deformed shape due to the live load, you go here to show deformed shape. Here, this thing feels like a deformed frame, and then you change it from dead to live. And then you will say, okay, then it's gonna show you how this is performing with the live load. The live load is pushing this in X direction, which looks okay. We are gonna see how this truss is not right. Yeah. You can. If we have time, I'm gonna talk about load combination. If not, we're gonna talk next time. All right, I'm gonna stop the animation, and let's look at the internal forces. Okay, let's see what is gonna happen here. I go to the internal forces. I'm gonna here this one. You can actually go to show display, and then you will show forces and stresses, and you will find frames and cable, or you can click just on this. When I click on this, I'm gonna show reactions. I go to join reactions, and then I wanna see reactions from the dead load. I'm gonna hit apply, and this is gonna show you how much Y reactions you have. And if you hit live and you hit apply, it's gonna show you what is the reaction do you have. And actually that makes sense. You have 5 comes this way, so the 5x the other way, and this truss needs to overtend this way, so there's other reactions balancing this. Yeah, 5, this 5 wanna overturn this truss, so there's a moment from 1.83 and 1.83. If you multiply them by the distance here, it's gonna give you the same moment that the 5 load is making. So reactions looks okay. All right, so let's see the internal forces. We know that trusses only have normal force, right? So let's see if this truss have bending moment. So the bending moment that we are looking at is bending moment 3,3. What is bending moment 3,3 is? All right. Let's say this is my cross section. This is actually the we call it the I'm gonna talk about the local axes for members, but the local axes for like this member, if I cut this as a section and I'm looking at this beam section, you have local x1 this way, it's in the x direction, and you have 2 this way. No, actually, this is 3 and this is 2. 2 going up and this is 3. So moment 3,3 is the one that we are looking at. And shear 2,2 is the one that goes around this way. Okay, so let's see. Here's moment 3. That means that the moment about x number 3. So if I hit that one and I hit apply, I will find out that this truss already has moment. And actually, it looks like a beam moment. Can you see? Feels like it's fixed here, and it feels like going all the way down like this, and same. That means that the SAP 2000 didn't feel this as a truss. That's actually an actual frame. That all the points are taking bending moments. So if this is actually a truss, all these points should have moment equal to 0 because they are all intermediate points. So I need to release the moment at all these members. So to do this, I have to unlock my model. I go to the lock and I unlock it. And then I'm gonna click on all the joints in my structure, and I'm gonna go to something that's called assign joint. Not here. Oh, it was frame. And you will find something that's called releases and partial fixity. So I'll go here, and this is not something on the joint, it's always on the frames, because you release the moment at the end and the start. So where it asks you, are you sure for all these frames you want to release something? Yes, I want to release the bending moment M33 at the start and the end of each one of these members. Okay, so I will click here and check here at the end, and actually it asks you what is the bending moment at that you want to what is the bending moment to stiffness at each one of these ends. I want to make the bending moment to stiffness at the end is equal to 0. Do you guys remember the rotational spring?
Yeah.
So if you have a rotational spring at these members and it has a stiffness, you put the stiffness here, but we don't have a rotational spring. Okay, so they are all 0, and then I will hit OK, and let's run the model and see what we are going to have. And then I'm going to run. I'm going to hit run now and see how the bending moment is going to look like when we run this model. Should be the moment equal to 0, right? There's something. Okay, all right. So right now, it made the moment equal to zero for all these members, but look, the moment here is not zero, the moment here is not zero, the moment here is not zero. Why? Because that was only one member, and we released the moment at the start and the end. So that means that we need to redraw this member and or divide this member at these joints and then release this member again. So that's also another mistake. So I'm gonna unlock the model. And then I'm gonna select this member and select the joints that I want to divide this member at. And you will find something is called edit. And then you will find edit line, divide frame. And then I'm gonna divide this frame at the joints at the break the intersection between joints. And then I hit apply and then I will hit OK. Or delete this frame and redraw it as a pieces. That's also another option. Okay, let's run and see what we are gonna have. Run now. All right. So, oh, I didn't release, sorry. I divided it, but I didn't release. Okay. So I have to apply the release for these members. Okay, I'm gonna assign frames, release, and then I'm gonna make it 0. I'm gonna hit OK. So the thing is, we divided, but we didn't release, so it doesn't matter. So we didn't do anything. We just divided the frame. I'm gonna hit OK. All right. So what is going to happen right now? We are going to see that the bending moment is starting to be zeros at these members. So we solved it part of the problem. What is the other part? That is there's bending moment. The bending moment should be on all members 0. So I shouldn't have bending moment in between the joints, right? Is that running? All right. So we solved the part of it, and it's okay. Oh yeah, you have to walk.
Yeah.
Oh,
That's
wow.
all right. Sorry.
I could explain.
It's stretching the legs.
Okay. All right. So right now we solved a bunch of the mistakes. So we have the moment at all the joints equal to 0, but this is still not a truss. Okay. Well, it's a truss because it has the moment equal to 0, but the moment in between is not. So you guys tell me why is that? Because you have on weight, right? The on weight. So right, this here between here and here. So that's the WL square over 8, WL square over 8, WL square over 8 for each member. So we don't have this in our problem. Let's make the on weight 0 and see what we are gonna have. I'm gonna unlock the model and I'm gonna hit OK, and then I will go back to define, load pattern, and then I will go to dead loads and I make it 0, and I modify this and I hit OK and then rerun the model. I try to mimic all the possible mistakes that you can do when you do the analysis. Definitely, there's other mistakes when it comes to different problems, but I'm gonna give you a trust for the homework. I'm gonna maybe upload the homework today. Just try to avoid this. That load is 0, release the bending moment at the start and at the end. You have to divide that frame so at each joint so that you can release the moment for all the frame members that you have. All right, so right now we have a bending moment actually, but there's no bending moment. I mean, like, look, moment 3, but the bending moment is equal to 0. So that means right now, everything we have done led to the truss system that we are modeling right now. So if right now we can look at the axial forces. So I can go here and I can show frames results, and you're gonna have an axial force, and then I will hit OK. So right now the axial force that we have on this truss is actually true. If you pick like from previous ones that we have done that has been a moment and you look at the axial force, it's gonna be different because right now it's a frame. And the frame, most of the loads are shear and moment. So you will find that the axial force are very, very small. But right now, this is the truss, and all the loads are transformed into tension compression. Okay? And from the results that I see right now, it makes sense for me. Like, usually in trusses like this that has loads, dead loads going down, there is a tension, and top is a compression. Okay, like if I go here, I'll find that the here is like positive and top is negative. Let's look at the live loads. Like if I hit live and okay, and see what is gonna happen. And that's also makes sense because you have a load is going this way, so all the diagonal members are on tension and these one are in compression. And this is a roller, it's getting pushed that way. So all these members are in compression and this one is trying to push the other side. So the values are making sense. I know it's a simple one, but I try to use it to demonstrate many things. Not only, this is not for the problem. Actually, to do this, it's gonna take, I don't know, 3-4 minutes to do this whole thing. We spent like over an hour just to show you like how to define materials, how to define cross section. Next time, I'm gonna do a test. So what I suggest is to go home, start SAP 2000 whenever you are ready, and try to do this step by step. Because in ETAPS, when you are gonna do your project, it's gonna be the same steps, and it's the same thing: edit, view, define, draw, select, everything. Okay. All right, sounds good. See you guys next time. If you have any question about the midterm, I'll be in my office until 12. Then I'm gonna have some meetings. So maybe use this hour if you have any questions about the midterm.
Are you here tomorrow?
I'm here like later. Like, do you have like the whole day off? Maybe we can do Zoom meeting. Okay. All right. Sure. Sounds good. Perfect. Okay.